Alright, so today we'll be talking about surface areas of pyramids and cones. Okay, and a lot of stuff that's going to be happening here. So right now we can't really deal with I guess, pyramids and cones, but you could move around the height. Now if you do move it around, you do need to pay attention to the altitude, because the altitude will definitely become the height. Okay, so just be careful with that. Alright, now pyramid is actually a shape in which you have the base, and instead of meeting with another base at the top, you actually have the lateral areas go up to a single point. This point right here, and this is called the vertex. Okay, and I believe, yep, there it is. Pretty simple stuff right there. Okay, so now the pyramid could have any base shape. It could be a triangle, it could be a square, a rectangle, rhombus, whatever you want. It's just going to actually, all the lateral areas are going to meet at a point called the vertex. Okay. All right. Now the lateral area, or first off, before we actually get there, let's talk about the net drawing, the net figure of each shape. Now, obviously, this is the worst drawing in the world of the net shape of an actual pyramid, but it's just basically four triangles. Now, sometimes depending upon the lengths here, these two triangles will be congruent and these two triangles will be congruent, but they might all four not be congruent depending upon the shape. Okay, and depending on the number of sides of the base, that's how many triangles you'll be dealing with. Okay, now if we were looking for the lateral area, obviously that would just be of the four triangles. I'm just using a square pyramid just in this case. You could have a triangular or a pentagonal pyramid, whatever you want to choose. Okay, now to find the lateral area, it's going to be 1/2 times the perimeter of the base. Now, if you think about that, the perimeter of the base is actually going to be all of the bases added up, okay, which are going to be the perimeter of the bottom shape, okay, which makes sense why it's perimeter of the base, times the slant height. Now, the slant height is the height of the triangle on the outside, so it's just going to be this length right here. Now, if you notice, okay, I can actually draw a right triangle here in the red. It's a little bit messy, but there's actually some really good stuff that you can get from this. Let me move this apothem down. Okay. All right. So the height is here, the apothem is here. If you know these two, you can use Pythagorean theorem to find the slant height of the actual pyramid. Okay. Now slant height is actually represented by a cursive L, something that looks like this. But as you can see, my attempt at it to very carefully draw a cursive L is not the best. So we're just going to leave it as slant height, okay? I'm just going to leave it as slant in the shortened version. So basically, if I add up all the triangles, I go 1/2 times the perimeter of the bases times the slant height, which is just basically a quick way of finding the area of all four of these triangles, okay? All right, that's just the lateral area. Now the surface area is going to be the lateral area plus the area of the base. So if it's a square, you're going to be doing length times width. If it's a triangle, obviously it's going to be 1/2 times base times height. It just depends upon what the shape of the base is. Okay, so remember, a pyramid is not a prism, but it is related to it. It doesn't have the parallel base on the top. Okay. Now, cone is going to be a pyramid with a base of a circle, and instead of meeting with another circle at the top, it meets at a point, which is going to be its vertex. Okay, so that's also a vertex. All right. The formula is actually going to be pi times radius times slant height. Now, that's not going to be the most exact formula in the world. As a matter of fact, let me double check it. I had to check it real fast because I thought this was radius squared. This is actually not radius squared, and it actually does come from the fact of the net drawing of the actual shape. Now, the net drawing of the actual shape, let me move it a little bit so it's a little bit better, is going to be a circle plus a circle sector. Okay, and that is just found by using this formula right here. Let's go back to it. Okay, so the lateral area is going to be pi times the radius times the slant height, and the slant height is going to be here. Now you can find the slant height also by knowing the height and the radius, and then doing Pythagorean theorem on that and finding the slant height that way. Okay, now the surface area is going to be pi times radius times slant height plus radius squared times pi. Okay. And the surface area is just going to be that circle pi r squared at the bottom plus the actual lateral area, okay, as we go through. All right, now just looking at all our definitions, let me see. Okay, slant area is the really new idea that you want to think about, but it's the slanted portion of our usual lateral faces on the side that we need to find, and we can easily find those by using Pythagorean theorems with everything, okay? Alright, so please understand. Now, the trickiest one of all might be finding the apothem, because you might need to do some trickiness with actually working with, I don't know, probably working with, let me see if we were able to do this one. Nah, yeah, the apothem's pretty much going to be given to you in the beginning. I can't imagine a problem showing up like that. Okay, so as long as you take your time and work with surface areas of pyramids and cones, I think you should be totally fine with working with surface area and stuff. Okay, all right, that's it. I'll talk to you later. Bye.